How does one plan for high availability for the applications, and how do we take care of scalability? That's what we're going to see. The first and foremost thing all of us have to understand is hardware and software will fail. Why it will fail, how it will fail, you will know as it goes by. But if you upfront realize that no hardware is going to be 100% up and running without any fault, or softwares will always keep running without any fault, first of all, we'll have to come out of that conundrum that nothing will fail. So let's first accept that everything is bound to fail. Then we can appreciate implementing fault tolerance or redundancy for the system by having duplicate hardware, duplicate servers with software running, etc. will increase the application's availability. And when you provision redundancy and fault tolerance for your system, your application's high availability is with respect to what you have built the fault tolerance. The cost of implementing fault tolerance varies. What level of faults you want to tolerate, accordingly you provision redundancy and replicate, or whatever you do, accordingly the cost is going to increase. Now, we cannot guarantee 100%. We strive to have 100% availability, but finally your business requirements will decide. Obviously, the funding you get will decide how much of replication, redundancy you implement. And there is always a remote chance that though you plan for so many different things, although redundancy fails at the same time, a very remote occurrence, but we need to be ready for it. That is why it is important we also take care of testing out recovery procedures, so that in case everything is fine, I will test out a recovery so that I know my recovery procedures are in place. What we need to remember is we provide availability for applications. We are not guaranteeing a given server will always be available or a given hardware will always be available. Infrastructure failures or data center failures are going to happen. It is just that larger failures are lesser likely to happen. Meaning one server going down is having more probability compared to an entire data center going down. But that is possible. And if you have planned that I need to take care of a data center going down, you would have upfront provisioned your hardware in another data center and replicated, and you are ready to tolerate such failures. Then comes scalability. What is the meaning of scalability? Many applications have a seasonal workload. What is the workload? Workload is when the system is being used. The hardware you provision for a given application will be based on what is the peak workload that is expected. What is the meaning of peak workload? This is the maximum concurrent access that will happen to do certain tasks. How many orders will I get on an average in a day is one metric, but in a given hour, what is the total number of orders to be processed? In a given minute, how many total orders have to be processed could vary depending on the time of the day the system is being used. Thus, you will size your infrastructure keeping the peak workload demand, because the peak workload is when your system is going to be tested for its CPU, memory, network, IO and all resources, and your system should be tested for these kind of peak workloads and certified that this can handle this workload. But at the same time, during non-peak times, your hardware will be idle. Now, in a typical on-premise infrastructure, you buy hardware and keep it readily available to meet whatever demand you have projected is going to happen. But the other times, your hardware is lying idle. In general, when we say elastic scalability, it means I will be able to scale up my resources based on the need. Now, in an on-premise infrastructure, you might have multiple applications, and if there's a sudden workload demand coming up, you might reduce the infrastructure given to other applications and give it to the system which is more important and which is having more work done. But you will not get the ability to dynamically scale up infrastructure if you don't have it with you. One of the major challenges in an on-premise setup is that when you need a sudden increase in hardware, unless you have procured and kept it with you, you don't get it. That is where public cloud makes a big difference, wherein you can scale up, scale down based on whatever the provider has made available. So far, what we have seen is generic understanding about all these terms, which is fundamentally the foundation on which we can appreciate cloud. Every cloud provider will have a framework, a list of terms and features that they have, using which a customer can take care of the high availability, disaster recovery, scalability requirements. What we have seen so far is the generic concept. Whichever way you set up your application, whether it is in your on-premise, it is in your private cloud, or you're using public cloud, your system should be available, your data should be available, your system should be capable of tolerating whatever faults you want it to tolerate. But each cloud provider might have different terms, different means of implementing it, which you need to learn from that particular cloud provider's specifications. In this course, you will learn how you should use OCI to take care of availability of your applications. How do you take care of disaster recoverability of your applications, which we will see in later videos as we go through various services. With this, I complete the generic concepts that are required for you to understand, to appreciate OCI services and the framework with which they have built the services and how you need to use the services. Hereafter, we will get into OCI specific services and their features.